This question needed a good sketch. It doesn't have to be perfect regular pentagon, and obviously circles. You don't have a compass or anything to do that with, but just try and draw them as accurately as you can. I can cheat a little bit here because I've got some software that will allow it for me. Now I've got my pentagon, and I'm told that I'm going to also draw two circles, one with a center on one of the points A and another on B, and they're going to be next to each other. So I'm going to turn my pentagon around just to make life a little bit easier for me. But it's no problem if you're working on paper. It doesn't really matter. You can just rotate the paper. And then I've got one circle with, oh, actually I haven't labeled it yet, so let me just do that. So A, B, C, D, E, for example. Okay, so circle centered at A is radius AB, so there we go. And then one centered at B goes to A, so that is our setup. And then I'm interested in the angle DEX, where X is this point here. So I could draw a triangle, but I think I'm just going to leave it like that for the moment. And I want to know what that is. And this point here is X. So where the two circles intersect. Okay, we've got a good setup. Right, now the first thing probably to think about is this regular pentagon. And the angles in the regular pentagon are 108. I'd probably show working for that here in this problem. So we're expected to show working, but it's the number of sides minus 2 times 180 divided by the number of sides. 180 divided by 5, well, we can divide by 10 to give 18 and double it to give 36. So 180 divided by 5 is 36. So 3 times 36, which is 108. You could also do 360 divided by 5, which is 72, and then do 180 minus that. Two different approaches. So, for example, this angle here is 108. Now, there's one other crucial thing to spot, and that is going to be that this is in fact an equilateral triangle. They all have the same sides. And we know that because we can see that they're both the radius of one of the, well, either one of the circles, basically. So I can now label these angles 60 degrees. Write this down as some working equilateral triangle and so on as you go for this problem as well. I'm just explaining it verbally. And we're well on our way now because I can now find this angle. It's going to be 108 minus 60. It's going to be 48. And then I can see that this is an isosceles triangle. XE is not necessarily the radius, or it's not the radius in fact, because that would be 60. But actually AE and AX are both the radius of circle A, so they must be the same length. And then I can do 180 minus 48, which is 132. And then I can divide by 2, give 66. So that angle there is 66 in particular. That's the one I'm interested in. Because finally, I know that this angle here, the whole angle is 108. So it's going to be DEX is going to be 180. Sorry, not 180, 108 minus 66. And I can work this out just by adding on to 66. So 34 to get to 100, add another 8, is going to be 42 degrees. All right, really nice geometry question there.